Hello everyone, my name is Gaurav Singh Rathore, roll number 20951A1223 from Institute of Aeronautical Engineering IT branch. Today we are going to discuss a topic implementing the quicksort. Now we will see how quicksort algorithm works. What is quicksort? This sorting algorithm uses the idea of divide and conquer rule. It finds the elements called pivot, which divides the array into two halves in such a way that elements in the left half are smaller than pivot and elements in the right half should be greater than the pivot. So now let us see the time complexity of quicksort first in best case, average case, and in worst case. We will also see the space complexity. The time complexity in the best case is the case when occurs when the pivot elements is the middle elements or near to the middle element. So the best case time complexity of a quicksort is O log n star n. So the average complexity. So the average complexity occurs when the array elements are jumbled order that is not properly ascending or not properly descending. The average case time complexity of quicksort is O n star log n. Uh, the worst case complexity. The worst case complexity occurs when the pivot elements is either greatest or smallest element. Suppose if the pivot elements is always the last element of the array, the worst case would occur when the given array is sorted already in ascending or descending order. So the worst case time complexity of a quicksort is O n square. So we will quickly see again the time complexity and the cases. In best case is O n square log n, average is also same. In the worst cases O n square. So to know the algorithm of quicksort, we need to remember three steps. First, find pivot that divides the array into two halves. Now quicksort the left half, quicksort the right half. Let us see one example. So we are considering an array having 6 elements: 5, 2, 6, 1 and 3, 4. Now we will arrange these elements in ascending order using quicksort algorithm. So this is an unsorted array in which the array index starts from 0, 1, 2, 3, 4, 5, and array elements are, we discussed, 5, 2, 6, 1, 3, 4. So the left is 5. It's initially pointing the first elements of the array, and the right initially pointing the last element of the array. So this is pivot. We will quickly sort this array now. Remember this rule first. All elements to the right of the pivot must be greater than the pivot, and all elements on the left of the pivot must be smaller than the pivot. As the pivot is pointing at left, so the right elements, so we will start from the right side, okay, and moves towards the left side. Now we will compare pivot with right. So our condition was pivot should be less than right, so this is false. Now we will swap. Okay, so this is swapped. 5 came to the ending position and 4 came to the first position. Now move pivot to right. Now pivot is came to the right position. Now we have to start from the left side. So basically now this should be greater than left side. हाँ सही है. So we move one position towards right. Now position goes to this. Now this is also true. Yes, 2 is less than 5. Now we will compare the next position. 5 is greater than 6. This is false. So now we swap pivot and left again and move the pivot to the left. Now pivot is pointing on the left. Now we will compare right element from right and moves towards left. So 5 is less than 6. Yes. Now we will move right. Now compare it with 3. Moving right, 3 is less than 5. So now we will swap this again. Left comes to right and right comes to left, and moving pointing. Now pivot is pointing towards 4. Yes. So we move left one position towards right. Now we will compare next position. 5 is greater than 1. Now both left and right are pointing at the same elements. So basically this time 5 is the pivot and it is at same. So element left on pivot are smaller and element right on the pivot are greater. So basically pivot has divided the array into two halves. The basically pivot has divided into two halves. Now both left and right are pointing at same element, and the elements left on the pivot are smaller and elements right on the pivot are greater. So pivot has divided the array into two subarrays, the left subarray and right subarray. Now we will quick sort both the left and right subarray. So now we will do for the left subarray. Now 4 is the pivot position and right. Now we will compare it with 1. So pivot is less than left. No. So again swap pivot and right. So 1 comes to 0 index position and 4 goes to third index position. Now move the pivot to the right. Now we will compare this. This is small. So basically the array got sorted. So we got the proper array in the ascending order of 1, 2, 3, 4, 5, 6. So this is how the quicksort algorithm works. First we divide the array into parts and compare the pivot with left and right. The elements left to the pivot element should be smaller and the elements right to the pivot element should be greater. This is how quicksort works. Now we will see the Python code for the quicksort algorithm. So we will define a partition A, start and end. So I is equal to start minus 1. So pivot is equal to A of end. So for j in range of start comma end, in this we applied a loop. So if we will compare if A of j is less than pivot, we will see I will become I plus 1. Now we will swap this. Aj is equal to aj comma I plus 1 comma an is equal to an comma ai plus 1 return. So quick functions to implement quicksort: define quicksort a starting comma end, a of array to be sorted, starting index comma ending index is equal to ending. If start is less than end, p is equal to partition a start comma end, quick a start p minus 1. So quick p a comma p plus 1 comma end. Now the driver code is define print array for I in range of length of n, print ai. So now we will sort a is equal to 68, 13, 1, 49, 58. So the output will come print. First we will print before sorting elements. Next we will use quick sort function and see the output has come. First it was unsorted 68, 13, 1, 49, 15. Now after sorting array element it will become 1, 13, 49, 58, 68. So with this So with this we will conclude our topic. Hope you like it. Thank you.